Hello everyone. Today we're going to create some basic plots using the Python language in the Jupyter Notebook. This is the Jupyter Notebook. It opens up automatically in your browser. I'll make another video or I'll direct you to a video probably because there are way better tutorials out there of how to install Python Jupyter and Python in general. So let's begin. We will select the notebook. Now, this is the Jupyter Notebook. It's quite easy to use. It contains cells. Think of them maybe, I don't know, as lines in your school notebook or as blocks of notes where you can share values defined here. So A equals 1, okay? A is 1. It's when you define a value, it's shared in between. The Jupyter Notebook is great for presentations. See your workflow. Maybe do your little your code prototyping instead of using an IDE. Depends on what type of programming, what type of programs you want to run. So we're going to start off with our imports, as I say up here, imports. We are going to use SciPy. SciPy is going to be used to perform linear regression. So we're going to import the linregress module. There goes that. NumPy is going to be used in order to make and manipulate arrays and values. So this is NumPy. In order to make our plots, we're going to use the basic and probably the mother of all, the back end, I would say, of a lot of the plotting software out there related to Python, matplot. So we're going to import matplotlib. The word as here and as it's for shorthand. Instead of saying numpy dot some function we want to use, we'll just say np dot the function we want to use. So import matplotlib.pyplot as plt. I'll show you later plt.what. What does it do? And the only maybe non-Python line that's related to the Jupyter Notebook exclusively is this magic command, which you would have to enter often in order to show render the plots within the notebook. So show a plot in here. Else you would have to write plt.show after every plot you set up, and a plot would appear with a pop-up as a picture. So let's start this. Oh, and to run each cell, you don't press enter because enter does this. You press shift enter. Boom, 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 boom. Okay, so now example 1. Let's plot the data. Let's define it. This is just a simple list of data. X equals this, Y equals that. Now, I will create another tutorial showing how to import data, because maybe you have like a million data, you know. I'll make a tutorial showing how to import it from files, Excel, CSV, also access a particular sheet in Excel. That comes in handy if you maybe want to split experiments or whatever into separate sheets, which I do recommend. So let's define it. Shift enter, and we're gonna plot these two lists. Enter xy plt dot plot. Boom. We make our plot. Maybe you want to make a scatter plot and color the points red. We'll say red. You can also add this color to the plot above. There's no oops, sorry, 2 commas there. Okay, there's no issue in doing that. You can also create a stacked plot. Maybe you want to have a plot and a scatter plot. So we'll name this, I don't know, blue. See how it looks? It's beautiful. So there goes that now. Now we're going to plot an array, and I'll explain why we use arrays. Let's say you have your data defined, but you want to also, before you make the plots, maybe you want to find the average and different other values involving your data. So let's define the data, and we will just simply use this command and enter the x value in the data. Okay, x, y, y. We could have even copy and pasted this in here, but that would be just overkill for no reason. We define a variable for this list. So we run this. Now, why on earth did would I do this? So xa, let's look at it. Okay, it looks the same as x. It is the same. It just has this array thing wrapped around it. So let's see what that offers us. And let's see what the lists don't offer us, which the list is this. So let's say I wanted to find the sum of a list. I would have to use this command, sum, which is a built-in command, x. Okay? We can do this to xa also. But here comes the main benefit of arrays. Arrays have these methods built into them, meaning I can click xa.sum, which is the same, it's similar to the instruction here, plt.scatter. We use plt to create something. So plt.sum, plt.sum. Let's say we want to find the mean of our x values, the mean, 4.5, standard deviation, and various other operations provided by NumPy. So let's plot it. It would appear the same as before as the plot above. plt.plot ya and xa, and that's that. Now, as I said, NumPy, the NumPy arrays are very useful because you can perform operations on them. Meaning, let's say we had the list, okay? X plus 10 does nothing. But xa plus 10, it would add 10 to all of the elements. Which is very time efficient. If you wanted to add 10 to all of the elements of a list, you would have to say for I in range of len of x, you would say x of I, equals, okay, x of I plus 10. Let's see x now, how it looks like. Boom. Instead of this. But, I mean, why create a for loop if the array can handle it with one command and way more efficiently? You can also multiply values times 10. Set them to a power to the 10th. This is how to set to a number to a power. Let's say you had 5, or you had the array. This is how you do it. Not with the caret thing. Doesn't work here. Anyway, so this is this. Okay, so how do we, let's say we want to use the x values and set them to a power of 2. That means we are generating the y-axis values for a quadratic equation. So if I say xa star star 2, and we'll just set that equal to a, it doesn't matter, you can set it equal to cheese. Okay, we'll say cheese. Okay, and we want to say xa versus cheese. So x versus cheese. We'll name it y now, so we can. Oh, and because I wrote y here, y is no longer defined as this. This is your new y now. In order to bring it back, you need to rerun the cell. Okay? So there goes that. And instead of setting a variable equal to it, we'll just put it in the arguments of the plot. Okay? And this is this. Okay. Big moment now. Now we need to perform linear regression. We set our values, okay? And I choose to put them into an array. You could just take x and y and put them directly into the linear regression function. There's no issue. There's no problem. I just like working with arrays. So let's perform a linear regression here. Just run the command Shift Enter. We get the slope, the intercept, the R value, which you would square later to see the goodness of fit or whatever. Let's see the slope. Okay, we would expect a slope of 1, 1, an intercept of 0, 0. As I said before, you can add values to the array, just like I added 10 above. So we would say, let's say we would add plus 10. So we would offset the y values by 10. Let's see what the intercept turns into. Boom, 10, because it's a times x plus b. Slope is a, intercept is b. So let's see, let's plot the regression line now for this data, for the scatter data. Okay, so what is the y-fit values? Y-fit is just the values that are generated using the parameters of the linear regression. Okay, so it's slope times our x values, right? Plus the intercept, which is 10. So y-fit, we'll name it y-fit. So let's make a plot. A scatter plot for our experimental data, and we'll plot our the x-axis versus the fitted data. Boom. Isn't that nice? Let's make this red. Good. So there's some differentiation there. As you can see, there are two plots in one plot here because I ran it in the same cell. It's very important. If you would run it in separate cells, the second cell would not contain the first plot. Same as here. There's no, this line is not here because I only ran one plot command. Okay, so as I mentioned before, we'll make multiple plots. Here we plot XA, the quadratic one, and we plot also the linear regression function we generated before. Now, a very important thing to note, that is a graph without a title and labels and whatever is probably a useless graph, most likely. So let's see this example. Let's go through it. Okay. plt.plot, okay, this is our quadratic. We can set a label. We'll label it quadratic, just like when you would name a series, let's say, in Excel. plt.plot, xa, ya, okay, ya, this is our linear relationship, so we'll name it the label linear regression. Okay. Here we set x-axis label, okay, it appears x-axis. plt y label, y-axis. plt title, we'll set the title. Okay, now check this out. Now there's no legend. I haven't activated it, meaning that the labels of the plots will not appear. So let's activate this. Okay, let's say we want to have a grid. You know, it would help us narrow that values with our eyes and see, you know, what area does the value on the y plot fall into. So we'll just enable the grid. And of course, we need to save this graph, or once you learn how to use the notebook, you may just want to keep it within the notebook and present this as your proof of work. There are ways to make it look like a book, you know, with text formatting and stuff, you know, like chapters, and have code included in it. It's pretty. The Jupyter Notebook is a pretty neat tool. Okay, so we need to save it. This means that it's saved in the same area as where the notebook is defined, created. Okay, you can customize the path. Maybe it's you want to back it up in Dropbox or any other software, Google Drive. It doesn't matter. Your computer, flash drive. I don't know. As long as you know how to get there. So let's see where it is. Oh, and something else. The font size. You can increase the font size. I'll show that later. And you can do so many things here. You can also, by entering some other commands above, center the graph, make them bigger. You want to make the graphs fit the whole screen. You never know. If you can't see well, make them big, you know. So let's see where our graph is. Graph is test. Good. This is it. This is not. It didn't save it as all this. If you go to the file where it's located, you can find it as a small little graph, and that you can put it in your Word document or whatever you want to do. Open Office. I don't know what you use. So that's that. And just to go through a little bit with the how do we get this heading format? Oh, and when you click on a cell and you press the B button, a new cell is created below. If you press the A button, a new cell is created above. To erase a cell, DD. Okay? And if you need help with the shortcuts, it's somewhere here. Help, yes. Keyboard shortcuts, and it would have a screen pop up. Anyway, let's say I want to write macaroni. Okay. Okay, this is not something that can be defined. But maybe you want to create a header. You press the number, you click on the cell, just like I click here with the mouse, and you press the number 1, shift enter, and it's that. Maybe you want to change the font size. You click 2, or the header size more accurately. You click 2, let's say 3, 4, 5, 6, 7. It just goes on. Sorry. So that's how I created these. So that's about it for now. I hope this helps. I mean, it's not the best video made. It's not the worst. But it's my first for now. I'll make better videos in the future. Have a good day, night, whatever.